the smaller turning effect. Next line, change the line, then write the quantity that tells us the quantity that tells us the turning effect of a force, the turning effect of a force about a pivot, turning effect of a force about a pivot is called moment.
About what?
About pivot, pivot, pivot
Mhm.
is called moment. Moment. Underline moment. Then next, write down note points. What is moment? So moment is the quantity which gives the information about your turning effect. That is the moment. Now, write down the note points. It is like the summary of all you have written. The moment of a force is bigger. The moment of a force is bigger if the force is bigger. The moment of a force is bigger if the force is bigger. Next point. The moment of a force is greatest. Force is greatest if it acts at 90 degree. The moment of a force is greatest if it acts at 90 degree to the object it acts on. It acts on. Next point. Moment of the force depend on the size of the force, and also how far it is applied. How far it is applied from the pivot or fulcrum. Another name for pivot is fulcrum also. How far it is applied from pivot or fulcrum. Underline both pivot and fulcrum. Now what does line mean? This turning effect or the moment depends on how much force you are applied. This is clear. If you are applying small force, the turning effect will be less. If you apply a bigger force, the turning effect will be more. Now also it depends from how far you are applying. Suppose you are pushing with your hand. Okay, so hand is near about to that pivot. But suppose you take a stick, a long stick, and you are standing on the end of the room and you just use that stick to open the door. Now what happened to the turning effect? It will be less. So also, suppose you are standing in the end of the room, you are using that stick and you are applying the same force as you are applying with your hand. But the turning effect will be less in this case when you are using the stick. Why? Because the distance is more. So the turning effect depends on how bigger the force you are applying and also from how much distance you are applying the force. Okay. Then right now it is measured by multiplying measured by multiplying the force multiplying the force by the perpendicular distance multiplying the force by the perpendicular distance of the line of action of the force from the fulcrum.
Can you repeat that sentence?
It is measured by multiplying the force by the perpendicular distance of the line of action of the line of action of the force of the line of action of the force from the fulcrum. Full stop. The SI unit is the Newton meter. Then write in the form of formula. Moment of wait, let me write. Moment of a force equals to force multiplied by perpendicular distance then write down the example. First write down this formula and make a box over it. Now let me share you the screen. Now see here, can you see the figure? Figure 10.1. Can you see it?
On the screen or on WhatsApp?
On the screen, The screen is shared.
Oh, no.
Can you see the screen?
No.
You can't see, wait.
Take your time. Now I can see it.
But what I want to see, that is not opening.
Oh.
Okay, leave it. I'll just draw it.
Or if it's easier for you, you can maybe send me a screenshot.
Okay, let me do that only. Now can you see the screen?
No. Like I can, but it's the home screen.
Now?
It's still the home screen.
You can't see the book page?
No. Yeah, now I can.
Okay. Now see. Can you see the figure 10.1? Now see here what is shown in the figure A. Just see the figure A. There is a hinge Hinge or fulcrum, this is the fixed end of the gate. Any door, this is the fixed end, hinge. Now this is 3 meter distance. From 3 meter distance, you are applying a force of 5 Newton. Now suppose the question is what will be the its moment, what will be its turning effect. So you know that how you have to measure. You have to measure by doing the multiplication of the force applied. Force applied here is 5 Newton. 5 Newton with a 3 meter distance. So how can you find it out? You just have to multiply it 5 into 3 and that to the perpendicular distance. Suppose it is the force you are applying and the distance you have to take, that should be 90 degree. Then only you can take that distance. Suppose it is in any angle, that you can't consider. Okay, you have to take only perpendicular distance. Force and its perpendicular distance to the hinge. That will, when you multiply both of this, you will get the answer of your moment of a force. So here it will be 15 Newton meter. So just draw it, then I'll explain the next figure.
Okay. Okay, then.
Now see, in next case, the force is applied in the midway. Midway means 1.5 this side, 1.5 another side. That means you are applying the force in the middle of the 3 meter distance. Now, how can you find the moment?
It's 5 newtons times 1.5.
Correct. Only you have to take that distance up to which the force is applied. Okay, you don't have to take the full distance. Even if the distance, the total distance is given in the figure. In the exam also, if the total distance is given, but you have to only take that much distance up to which the force is applied. Okay, as all the distances useless. You just have to take the perpendicular distance between the force applied and your hinge or the pivot. Okay, so it will be a 5 into 10.5. You can write it like this. Give the figure A and figure B name, and then you can write like this only. See, moment of F about O. 5 Newton into 1.5 meter equals to 7.5 Newton meter.
Okay, then.
Then write down the turning effect of F is greater. The turning effect of F is greater in first case. In first case, This agrees with the fact that a gate opens most easily most easily most easily when pushed or pulled when pushed or pulled at the edge at the edge farthest 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 from the hinge. What does it mean? When
The
you
further away it is from the hinge, the easier it is to push or pull.
suppose you are opening a door, so the turning effect will be maximum when you just use that handle, and handle is at the other edge, just opposite to that of the hinge. Okay, that is the reason why the handle
Mhm.
is placed at the edge, because it is more easier to push or pull from that edge. Otherwise the handle can be in the middle of the door also, but with the middle of the when it is the middle at the middle, so the distance from the hinge will be less, so the moment will be less, so it is difficult to open when we are pushing from the middle of the door. Clear?
Clear.
Next, write down applications of turning effect. Application of turning effect. Number one, using a crowbar, using a crowbar to a, lift a heavy slab, to lift a heavy slab, hyphen, pull, pull near the end of the bar, near the end of the bar, comma, and at 90 degree, and at 90 degree, to have, to have biggest possible turning effect, biggest possible turning effect. Biggest possible turning effect. Number two, lifting a load in a wheelbarrow, lifting a load in a wheelbarrow. Second, the long handles, the long handles help to increase, help to increase the moment of, help to increase the moment of, the moment of lifting force, lifting force. No, other than this, other than the example of the opening of the door where the turning effect is required, we have two other application also. Now see, I have sent a picture in your WhatsApp. See?
Yes, I saw it.
Now see, in first picture, what that boy is doing? Suppose there is a huge stone in the middle of the road, and he wants to just remove that stone, and it's impossible to push it and remove. So what the technique used is, this is the technique how they can just remove the stone. They can put a one long rod below under that stone make the use of the concept of the turning effect. They just apply the force in 90 degree and the stone get lifted up. Okay. Similarly, in the second picture, I think this type of thing you have done seen when there is some road construction or something. So when there's a heavy load is there, so again the concept of turning effect is used. They just use this kind of trolley and it is known as like wheelbarrow. This is that more technical word, or otherwise it's a trolley only. Just again make use of turning effect of the force, apply a little amount of force, and the huge weight is can be taken from one place to another. So these are the two applications where the turning effect can be used, other than the opening of the door. Okay, so you should remember the name. First one is crowbar. Crowbar is that long rod, crowbar, and another one is wheelbarrow. So these two words are important. Again, I'm saying in this chapter the words are important because the words are something new. Fulcrum, pivot, hinge, crowbar, some new kind of words are there. Otherwise, everything you have seen practically, everything is known how the door is opening, how the turning effect will be higher, everything is known. Just the technicality or the wordings are important in this. Okay, from this chapter, mostly MCQs will be coming. Okay, there is no big kind of questions coming from this chapter. Rarely asked. Yeah.
Clear.
Now, next heading, balancing a beam. Balancing a beam. What does it mean, balancing a beam? When I start dictating, just have a thing in your mind. Then, have you seen a seesaw in a park?
Yes.
Now you know the concept how the seesaw is balanced. When the weight on the both side got balanced out, then the beam is balanced. So it's just like the same thing. Okay. So first write down. In a seesaw, suppose a small child is sitting on, in a seesaw, suppose a small child is sitting on the left end. Left end. Her weight causes, her weight causes the seesaw, her weight causes the seesaw to tip down, to tip down on the left. Her father presses down, her father, her father presses down, her father presses down on the other end, on the other end. If he can press with a force greater than, with a force greater than her weight, her weight, the seesaw will tip to the right, will tip to the right. Up to where you have written?
It will tip to the right.
Will tip to the right and she will come up in the air. She will come up in the air. Next, change the paragraph. Now suppose the father presses down. He will have to press, he will have to press You will have to press with a greater force to overcome the turning effect, to overcome the turning effect of his force, to work, see, write down the turning effect of his daughter's weight. The turning effect of his daughter's weight. Turning effect of its daughter weight. What does it mean? Suppose there is a seesaw. Okay, it's like this. Now suppose here there is a child sitting in this side. Once the child got seated in this seesaw, what happened? The seesaw will be tilted. It will become like this. The child
Mm-hmm.
will sit in the ground. Now suppose father is standing on this side. Now what he is doing? He is pressing the seesaw. Now he have to apply the force greater than her weight. Then only she will move up. Suppose he apply the same force as his weight. So what happens? It will again come back to this situation, horizontal situation. And when he apply the force greater than his weight, what happened? The seesaw will move like this. The girl will be in the air. Correct? Now
Yes.
he have to continue to apply the downward force so as to continue her daughter's weight, and so that she can be in the air only. Suppose he leave and he don't apply the force in the opposite side, what happens? The daughter will come down again. Now what is happening? There is a turning effect. Again there is a turning effect. How the turning effect is applied? The father is applying the force in the downward direction. The father is applying force in here. Now what is happening? The force causing the child to go up and down. So this is a like balancing of a beam. This is a beam. That pipe or that rod is the beam. Now we have to balance that beam. So in order to balance it, what the father needs to do? He have to apply the same force as the daughter's weight. Suppose he applied more force, what happened? She will go up in the air. Again, if he releases the seesaw, if he just start removing the force, whatever he is applying earlier, what happened? The girl will come down and she'll come in the balance position. Again, if you release